A warm welcome from Germany. My name is Carsten Blank and I am the Managing Director of Data Cybernetics. I am happy to have you here as my listeners today. May I take this opportunity and congratulate you on your way into the journey of quantum computing, a subject very dear to me. Today I want to talk about our company's projects in total, the product visions that we strive for, and all the technical solutions that we propose as the challenges of these go by. In particular, as the title suggests, I want to talk about our scalable cloud access to quantum computing. My interest in quantum computing is more than a mere fascination. Together with Professor Daniel Park from the Yonsei University in Seoul, we participate in research in an internationally recognized level. It is this combination that lets me speak as a person that looks on quantum computing from a science to business perspective. Thank you very much again. Let's start.
Let me first give an introduction to Data Cybernetics. We are a technological and scientific consultancy that helps businesses to tap into innovative solutions. Our emphasis on applied research and scientific programming supports our clients' claim to stay on top of technology. The strong focus on software and data engineering brings our technology visions to life. Our job is more than just innovation and consulting. We deliver 24/7 capable solutions. Our company was originally founded by Philipp Leser and myself in 2016. With our recent growth, we scaled up from a consultancy only to a technology startup in 2021. We are located near Munich, Germany, in the town of Landsberg. In order to learn more about the kind of projects we have done with clients, let me go through these on a high level. We have been working on optimal technical and commercial control of virtual power plants, demand forecasting in logistics, energy trading algorithms to benchmark the performance of an energy trading desk, energy consumption forecasting, time of usage optimization for smart charging, route planning in warehouse logistics, predicting delay of railway traffic, an interesting and ongoing project visible to all German railway customers. Associated to this project, we also have massively parallelized batch and stream applications, ancillary service market outlook predictions for offshore wind systems, and finally, software consulting for a quantum hardware scale-up. As you see, the list is long and showcases our expertise in a number of different areas. Since the beginning of this year, we have been granted government money to develop the software for a quantum computer. I will go into some more detail on this project, which is called RIMEX-1, funded by the Ministry of Education and Science. In its wake, two projects have been commenced as spin-off technologies, the Q-Alchemy product portfolio and the HTO API framework. Within these projects, first visible results, accessible for the public, shall come in existence in the next months. Let us describe them. Our own suite of quantum computing related services, which we call Q-Alchemy. This project has two initial products. A product that supports in converting your data into quantum data. This product has been the result of research with the University of Pernambuco in Brazil. Also, the optimization platform that solves QUBO problems with semi-automated decision-making on which of the solver, the Fujitsu or Gurobi, a mathematical QUBO problem is to be solved. A technology framework that we are developing for fast product development is the API framework HTO that enables us to scale quickly in an organized and extensible way. Its inherent AI capabilities will help us integrate machine-to-machine systems easier. The RIMEX-1 project constitutes a serious involvement with quantum computing. Based on ultra-cold atoms that can be treated as Rydberg atoms, the Rydberg blockade effect is used to solve certain mathematical optimization problems. The project envisions the construction of the lab equipment, the control hardware, and the software to control the system state. Also, connecting the state to the cloud and handling HPC requests is an important feature. This project constitutes one of the few big research projects that the government has accepted and is funding. Its main objective is to connect users to this Cold Atoms Rydberg quantum simulator. The algorithms to solve are unit disk maximum independent set problems using quantum annealing or the quantum approximate optimization algorithm. The users shall be mainly HPC clusters. Hence, one must handle thousands of nodes that each needs to solve a subproblem on a quantum computer. Generally, all problems shall be encoded in QBOs, quadratic unconstrained binary optimization problems. Additionally, a benchmarking will be undertaken to show the current quality of service with respect to the current state of technology of optimization. Our mission in this context is to create the middleware, the software that connects the users to the hardware. In this respect, we are implementing access and job management, handle IT security, and settle the usages in a procurement step. On the other side, we will create the control and planning of laser pulses and readout, as well as monitoring and analytics. Our company is central in this project as it touches the most important parts. As we also have a strong commitment to science and research, we are looking forward to great collaborations and many deep tech learnings. Q-Alchemy now is our own commercial suite of quantum computing related products. We are aiming at providing a computational platform that will be able to solve computationally expensive calculations within an HPC-ready framework. We are implementing a spin-off system from RIMEX-1, one that will use the Gurobi and Fujitsu solver to handle optimization requests of QUBO-encoded mathematical optimization problems. But we are also edging into modeling of energy systems, their market outlook, and contracting modeling. Maybe we'll have the chance to handle certain chemistry-related problems also over the platform. One of the most exciting topics I personally find in quantum computing is the issue of compiling an algorithm to a quantum architecture. In this spirit, my collaborators from the University of Pernambuco and I have devised an algorithm, the so-called bounded approximation error algorithm, that supports to bring data into the quantum world. This is a computationally complex algorithm that profits from our platform. This service will go available within the next 3 months with all features necessary for a full digital product. Here we see the architecture of our computational platform. It handles computationally intensive tasks given from users on the left. These are either humans using website or programmatic access through SDKs. The API hands out resources and takes tasks or actions to modify resources. Events let the user keep track of long-running jobs. The cloud-based architecture handles all necessary details, like job management, identity and user management, monitoring, data storage, and of course any pre- and post computations. In this image, we have put the optimizers on the right to show the target of the computational loads. The bounded approximation error algorithm, or BAA for short, has been broadly introduced 2 slides ago. Its goal is to create from data, we mean classical data, a quantum state which has significantly fewer entangling operations for an adjustable error. This can improve the end-to-end performance of any algorithm greatly. An example can be seen in an image here, in which my collaborators and I compare the state-of-the-art method and its performance on real quantum devices, in this case the IBM Q, versus the BAA applied to the IBM Q. The results truly speak for themselves. The principal idea is shown on the right. Given data, a state vector, one finds a low entanglement substitute with optimal fidelity. Thus, from the partitioning of the quantum spin system, the proper circuits and pulses can be created. The Q-alchemy is a full product, not a proof of concept. It involves user management, subscription and payments, tracking and auditing, full control over the computational loads and a graphical user interface, as well as SDKs for programmatic access. Furthermore, we have EU level of legal documents handling contracting details and general data protection regulations, or GDPR in short. Our API framework we have named HTO. This API framework is used on a microservice architecture with an AI-enabled dual human/machine-to-machine interface. This framework is our flagship technology with which we want to solve tomorrow's web-based challenges, namely natively adding machine-to-machine support as well as AI-driven decision-making. After all, this framework will support all our and our clients' digital product ambitions. Here we take a glance on the 4 pillars on which the goals of this API rest. The technologies that make up these frameworks are hypermedia, task-based API, event sourcing, and push notifications. These technologies thus enable organizationally scalable architecture, meaning that teams can be efficiently deployed, generic and extensible, auditable and explainable, AI-enabled, meaning that we have semi-autonomous decision-making integrated. Thus, we have a scalable human-to-machine and machine-to-machine interface. Now it is time to unveil the meaning of HTO. It is rather a technical term, hypermedia task ontology. Well, now next I want to talk about the business perspectives on quantum computing in Germany. As Germany has its unique strengths, I want to highlight a few of them that we have perceived so far. We base our assessments on what we hear from the news, from personal conversations, and from government activity. Certainly, known internationally is the German precision. Albeit, this seems to be a myth when taken as a whole. In certain areas, this seems to be exactly true. Looking into quantum tech, we see many hidden champions that are active on an international level, provided the finest and most precise instruments or technology. Therefore, Germany seems to be a good location to develop a strong quantum hardware industry from which the world will nurture. We found applications of quantum technologies not only in the computational realm, but also most remarkably in the quantum sensing community. Also renowned is the strong intellectual capabilities that exist at Germany research institutions on the fundamental physics level. Recently, the German government has invested a substantial amount of research and industry funding to bolster Germany's already impressive standing. As the development of quantum technologies are on their way, we want to look into the customer market of Germany, the end users. In many parts of the country, middle-sized companies make up for the industrial strength on which its society is proud of. These are usually family-owned and have about 400 to 1,500 employees. Even though many act on an international level, they are local in the structure, meaning they are interconnected socially in their specific area. Many of these companies are either indirect or direct line connected to the automotive industry. For most, their businesses are therefore facing high price pressures from their bigger customers. It is therefore the most important task for them to reduce their costs and risks. Prominently, we see an interest in more efficiency in their applied R&D efforts, as well as increasing the level of digitalization and automation. But also, operative risks are a factor, and being able to decrease these is of high value. What we often hear is that computational bottlenecks are of little concern. They are not the biggest pain point. The spearhead of research is also not attractive, as often the technology is not matured and therefore introduces more risks rather than reducing them. Now, how does the business structure look like in Germany? What structural situation do we find? And I want to again stress that this is only our experience and it may, in the end, be a lot different for others. As a consultancy, we are interested in giving interested companies advice on where and how to start on their quantum journey. Here is what we learned. The industries that we talked to were very focused on the so-called gain for the buck project. This means that the core of German middle-sized companies will spend money if there is an immediate or short-term payback. Investments in long-term gains or even risky ones are reduced to an absolute minimum. As already mentioned, most middle-sized companies are held by families. These are concerned about their social impact and the financial security of their employees, as with their companies. This makes them attractive employers and well-perceived businesses, but makes them risk-averse. Germany has introduced a tax incentive for research and development projects. The tax deduction scheme has indeed attracted many applications, but their effect is yet to show. According to the new tax law, up to 15% of approved R&D activities can be repaid by the government if the research is done from external sources. In fact, it is even 25% of total expenses if these activities were done internally. Therefore, there is a strong incentive to spend more money on R&D, an effect that will support consultancies and providers of R&D services. Currently, we see less investment on quantum computing from a majority of businesses so far, taking the structural situation at hand, and these incentives also playing out still will take some time. So the question for us is, what needs to change to tap into the champions of the German industry? In fact, quantum computing must reduce risks or costs. Can that be done? As quantum computing is a new technology, it will increase risks rather than decrease it. So it must mature in order to gain confidence in its value. Also, if it was to be shown that quantum computing must be adopted early in order to achieve great cost savings or exceptional risk reduction, many companies would invest in it now. Interestingly, while surely present, a fear of missing out decision-making is avoided when making business decisions, such that they are more rational. To summarize, the technology must clearly demonstrate superior qualities or must mature. Taking all these considerations of the German end-user industry into account, what are our goals? As a company, we are looking for customers. We are offering expertise in the already mentioned technologies. These are our expertise in the HTO API framework, in particular the support of digitalization. We are looking for customers with an interest in technical innovation. And of course, we are experts in consulting and are looking for clients in particular in data science, quantum computing, software engineering, and energy markets. Within the quantum technology, our goals are to support the NISQ era with our data to quantum Q-alchemy product and expand on this idea, while also building a computational platform as the optimization solver product. The scaling of our team and the technology development has been achieved this year, while we expect to find new customers and markets next year.
At the end of our short presentation, it is my pleasure to thank you for your valuable attention. Now, let me leave you with some words of Feynman himself. Nature isn't classical, and if you want to make a simulation of nature, you'd better make it quantum mechanical. And by golly, it is a wonderful problem, because it doesn't look so easy. I think we're all on the journey just to find out how wonderful that problem really is. And together it is much easier. So I stand with my motto, progress is a joint effort. I would really love to hear from Korean quantum computing, and I wish I would have been here today with you in Busan. Now, I would like to finally thank you for your attention and wish you a very pleasant day with many good and insightful discussions.